Let's look at a couple examples for related rates. A car is 40 miles east of a landmark and a truck is 60 miles south of a landmark. How far is the truck from the car? So let's look closely at this one. Are there any rates, miles per hour, inches per feet? Is there any something per something? Are there any rates? Is there anything changing? This one says a car is 40 miles. So it sounds like it's parked east of a landmark, and a truck is 60 miles south of a landmark. So there's nothing changing here. It doesn't say the truck and the car are driving towards each other or away from each other. There's no change. So this is just a Pythagorean theorem question. Now, when I do a question like this, I like to draw a picture. I'm not much of an artist, so my pictures are sometimes not that great, but it helps me to visualize what's going on. So for example, here's going to be my landmark. There we go. And it says that a car is 40 miles east. So this dimension here would be 40 miles. And here's my car. There we go. And then it says a truck is 60 miles south. So let's draw a truck. There we go. So we get an idea of the picture. So we have our truck 60 miles, we have our car 40 miles, and we have our landmark. This one, nothing's changing. So this is just a Pythagorean theorem question. So let's do a quick review. Pythagorean theorem says a squared plus b squared equals c squared. A and b are the legs that form the right angle. We know this is the right angle because of our directional notation here, east and south. East and south are 90 degrees of each other. So our C is always the hypotenuse, which is the side across from the right angle. So in this case, the distance between the car and the truck would be side C. Let's fill in what we know. It doesn't matter which one is A and which one is B. So I'll make a 40. So 40 squared plus 60 squared equals C squared. 40 squared, well, 4 squared is 16, and then put on your zeros. 60 squared, 6 squared is 36, and put on your zeros, equals C squared. So we got 5200 equals C squared. And then if you type that into your calculator and you take the square root, it looks like it's going to be 72.11 miles. Now we know it's not a negative because we can't have the distance being negative. We can't have distance in the negative direction, but we can't have a negative distance. So we'll go with the positive square root. So this one is just a Pythagorean theorem question. Let's look at the next one. Two cars start moving. Now we have a rate of change. Something is moving. One travels south at 60 miles per hour. The other travels west at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So now we have motion. Now we have rates of change. Now we have things that are moving. So this one's a related rates question. Let's start with a picture again. So two cars start moving from the same point. So no landmarks to draw this time. It's the same point. There we go. There's a point. One travels south. Here it goes. At 60 miles per hour. And the other travels west at 25 miles per hour. At what rate is the distance between them? The distance between them is this distance right here, increasing 2 hours later. So we have a little bit of information. 2 hours later. All right, let's think about what we know. We know our time is 2 because it says 2 hours. What would our X be? How far would this car have gone? Well, look right here. It says that it's 25 miles per hour. The rate of change is 25 miles per hour. So if it's gone for 2 hours, it would be 2 times 25, which means the car is 50 miles from where it started. The car that's driving south, let's call that Y. Same idea. It's been driving for 2 hours at 60 miles an hour. So it would be 120 miles from where it started. We don't know Z. Maybe we can figure out Z. What do you think? Can we use our Pythagorean theorem? Can we get Z? This would be our Z right here. Because we have A and B, it would be C, X, Y, Z. You can use A, B, C, X, Y, Z. It's all the same. So this one right here, we're calling our X. So this right here is our rate of change. So that's our dx dt. This we're calling our Y. So this would be our rate of change dy dt. We need to know the rate at which the distance between them is changing. So dz dt is what we're trying to figure out. Excuse me. We cannot have more than one unknown. So we're going to need to figure out z so that dz dt is our only unknown. So let's see if we can figure out z. Well, we know that x is 50, so 50 squared. We know that y is 120, so 120 squared will equal z squared, because that's our Pythagorean theorem. That's our a squared plus b squared equals c squared. So Pythagorean theorem. Let's solve it down. 50 squared is 2,500. 120 squared is 14400, and then equaling z squared. So add those together, we get 16,900. So 16,000. Whoops, one more zero than we need. Let's fix that. Is equaling z squared. Again, we can't have a negative distance, so we're going to use the positive version, which would be 130. All right, let's see what we've got now. Let's put our Pythagorean theorem over here. A squared plus b squared plus c squared, or you can think of it as x squared plus y squared equals z squared. We have x, we have y, we have z, so let's use this one. It's the same thing. Take our derivative, 2x dx dt plus 2y dy dt, 2z dz dt. All right, now we've got a derivative, so let's plug everything in. 2x we figured out was 50. Dx dt we found was 25. Y we found was 120. Dy dt was 60. Whoops, forgot the 6. Let's fix that. 2. Z we found was 130. Running out of space over here. And we're trying to solve for dz dt. Let's squeeze that in right there. There we go. So let's do some adding over here. 2 times 50 times 25. Do our multiplication first. 2 times 120 times 60. 2 times 130. And then they have our dz dt. So if we add these together and then we divide by 260, it looks like we're going to get 65 miles per hour is equaling dz by dt. So from here I continued over there.